Hello students, today we're going to be multiplying radicals, and this is a pretty easy section compared to some of the other ones in this chapter because it's so straightforward. And we're also going to be, after multiplying them, simplifying them. So we're going to keep doing what section 1 and 2 did in this chapter. Okay, so the first thing you need to know is to multiply radicals. Like, let's say we had these two radicals. You have to have the same power to the radical. In other words, this number right here needs to be the same. Okay, so that n, or you're not going to have a variable there, but if it's a regular square root or a cube or a fourth, they do have to be exactly the same. So in order to multiply both of these, it means I'm just going to go x times y, and that n, or that power of the radical, is going to be the same. Okay, so let's go ahead and do some examples so you see what that looks like. So in example 1, we're going to multiply the square root of 2 times the square root of 3. And what that will equal is the square root of 6, because I just did 2 times 3. And then you say, can I simplify that? And no, I cannot simplify that one. Okay, I'll do some that where you do simplify them in a little bit so that you can see what that looks like. Okay, so example 2, we have, I'm going to switch colors. Okay, so we have 3 times the square root of 2 times 4 times the square root of 5. Okay, so when you're multiplying these where you have numbers in the front, you're just going to multiply the two numbers together. So 3 times 4 is 12. And then you're going to do the radicals or the square roots by themselves. So 2 times 5 is 10. Okay, and that's it. So we're multiplying the coefficients, the first numbers together, and then the numbers underneath the radical sign. So this is your answer for example 2. Okay, before I do another one, I want you to do one on your own. No, let me save that for after example 3. Okay, example 3 is going to be the square root of 12 times the square root of 4. So when I solve this one, I multiply those two together, and I'm going to get 48. But I don't want to stop there because I know that I have more numbers that can be, I know that this can be a square root of something. So I'm going to do my factor tree like we learned in the last one. Now I know it's 4 times 12 because I had 4 times 12 up here. Okay, and then this is 2 times 2, and 12 is 3 times 4, which is 2 times 2. So look at all these primes I have right here. So now when I do the square root, I have 2 times 2 times 2 times 2 times 3. So I'm going to circle groups of 2 because this is a square root. So there's a group, and there's a group. And then I'm going to bring both of those to the outside. So really I have 2 times 2 that goes on the outside, right? So that's 4 times the square root of 3. Okay? Okay, now I want you to do one on your own. So this one's going to be example 3b. This is on your own. And I want you to do the square root of 5 times the square root of 35. Okay, so go ahead and hit pause and solve those on your own. Okay, now that you're back, you could have done this. Let me show you a different way to do some of these. So you could have multiplied those together and gotten 175, right? And then done your factor tree. Or to make it a little bit easier, you could just put them together like this and then say, oh, my factor tree, that's 5 times 7. So now I have 5 times 5 times 7. You see I have 5 times 5 times 7. And now I circle the 2 that are the same, bring that to the outside, and the 7 stays inside. And there's my answer for example 3b. Okay, we have 6 examples today, so let's move on to example 4. And this one is going to have a cube root. So we have the cube root of 1125 times the cube root of 63. So now, see, instead of actually multiplying these and getting this even bigger number, I'm just going to do 2. Okay, this is going to be the same as putting these both under the same one, right? Times each other. But I'm going to do 2 different factor trees because then that will help me figure them out. I'm going to do this one first because it's pretty easy. 9 times 7, 7's prime, and 9 is 3 times 3. Okay, now I can come over here and do this one. I know it ends in a 5, so it's going to be, I can do it times 5, right? And that one ends in a 5. So again, I can do a 5. And then this one is 5 times 9. 9 is 3 times 3. Okay, so I did 2 different factor trees, but because they're all underneath the same cube root sign, that means they all go together. So I have 4 3s, 1, 2, 3, 4. I have 3 5s, 1, 2, 3, and I have a 7. Okay, so now I'm going to group them. This is a cube root, so I'm going to group them in groups of 3. So you see what I grouped it as? So that means on the outside, I'm going to have a 3 and a 5, so that's going to be 15. And inside, I have 3 and 7, so that's going to be a 21. So my answer for that is 15 to the cube root of 21. Don't leave out that little 3 like I almost did, okay? You have to make sure you have that for the answer to be right. And so there's my answer for the cube root. Okay, so I want you to do, no, let's keep going. Let's go to the next example, and then I'll have you do one on your own. Okay, so example 5. We have multiplied the square root of 6ab times the square root of 2bc. So this one's a little bit different because it has variables now. So I'm going to put it all together, and I'm going to do this a little bit different just to show you something. Okay, 6 I know is 2 times 3, right? So I have 2 times 2 times 3 all inside of here. And then I'm going to put out all of my variables, and I'm going to write them all out instead of putting any exponents. Okay, and now I can circle my doubles because this is the square root. So there's a 2 and there's 2. So those are going to come to the outside, so 2b. And then inside I have 3ac. And there's my answer for example 5. So now I want you to try one of these on your own. So example 5b, you'll be on your own. And we're going to have the square root of 5a squared b to the 5th times the square root of b. Okay, so hit pause and try that one on your own. Okay, now that you're back, we only had one number here, 5, and that's a prime number, so that's good. And then I can write out all of my variables just to help me with circling doubles. So I have 2 A's, and then I have 2 B's here, 2 B's here, and 2 B's here. So all of that has to come outside. The only thing that's staying inside is the 5. So now on the outside, I'm going to have an A, and then I'm going to have B cubed because I had 3 of them circled. And that's my answer for 5B. Okay, last one, we're going to do example 6. And all these examples are in your book. Okay, we're going to simplify the cube root of 4x squared y to the 5th times z times the cube root of 8xy. Okay, so now when I write this, before I write them all together, I'm just going to go ahead and do a quick little tree because that just makes it easier for me. Okay, now I can do my cube root with all those numbers in it. So there's actually 5 2's. And then my x's, I have squared here and an x here, so that's 3 of them. And then my y's, I have 5 here and 1 here, so that's actually 6 of them. And then I have 1 z. Okay, this is a cube root, so I'm going to circle every 3 numbers. So there's 3. There's 3 x's, and then I have 3 y's and another 3 y's. So now when I pull those things out, I'm going to have, well, let's do the ones that are left inside. So what's left inside is 4 and a z, so 4z. Now for the outside, I have a 2, I have an x, and I have 2 of these for y's, so that's y squared. So this is my answer for example 6. So hopefully that's not too complicated, and if you just take it step at a time, you should be able to solve these. So that's it.